Welcome to maths class and your teacher Black Adam. So we have equation for convergence is -1 less than ratio less than 1. So looking at the values that we have, we need to find our ratio. Our ratio is 1/2 or it's 2/4. So that gives us half. It's the same thing. So we have -1, which is less than half, which is true, and then it's also half is less than 1, which is also true. So that way it does converge. So the geometric series does converge. That's our answer. And then we move on to 2.1.2, calculate sum of infinity. So sum of infinity, our A is 4 and our ratio already calculated, that's half. And then we have sum of infinity, which is A over 1 minus ratio. So that will mean that our A is 4 and our denominator is 1 minus half. So that gives us 4. 1 minus half is half, so it's 4 divided by half. How many halves you can get into 4? That's 8. Alright, so it's 4 times 2, that's 8. So that makes our sum of infinity is going to be 8. So that means no matter how many times you can keep adding on the series, you still end up with something equivalent to 8. Alright, that's our answer. And then welcome. Then next is we go to the next question, and then we are given the sigma notation. And then from the sigma notation, we know that the bottom starting part is k up to the 10th term. And then now first term is 3 to the power k minus 1. And then n, to find number of terms, we're going to take the upper limit minus the lower limit. So that's our sigma. We have upper and lower limit, that range, plus 1. So we're going to see that we have upper there is 10, number of terms is 10, minus k plus 1. So that makes k is equals to 11 minus k. So that's the number of terms, which is n. The other thing that we're going to do, we're going to change the sigma notation into the sign of n terms, which is as n is equals to a r to the power n minus 1 all over r minus 1. So we know that our first term, according to the sigma notation, it's that's our first term, that's 3 to the power k minus 1. And then we have sum of 10, which is we're given as 29520. So let's check the r. So okay, we don't know what term that's first or second or whatever. So that's 3 to the power 2 minus 1. That's give us 3. You can put 1 will give you 0, which is 1, and then we're not sure about the 1, so we use 2, 3, and so forth. So 3 minus 1 is 2, 3 to the power 2 is 9, and then 3 to the power 4 minus 1, which is that's 3. Then that is going to be 3 to the power 3 is 27. So r there is 3 over 9. It's gonna be 9 over 3. So term 9 over 3 or 27 over 9. So r gives us 3. So that's how we find our r right there. So the next thing that we're going to do, we're going to use first term is 3k, and that one there is 29520. It's 29520. That's sum of 10 terms. And then brackets, we have our r there is 3, and n is going to be 11 minus k. So that's 11 minus k, and then minus 1 all over 3 minus 1. So 3 minus 1 is 2. And we're going to use the calculator. 2950 2950 is equals to 3k. We add, remember the base is the same, so we add the exponents. 3k plus 11 minus k. So that's going to be minus 3k minus 1 all over 2. and then when it's all over 2, so okay, the k cancels out, and then we have -1 plus 11, and then multiply by 2. That gives us 11. -1 plus 11, that's 10, so it's 3 to the power 10 minus 3k dot 1. I think should be -1. Yeah, 3. Okay, so 59040. Okay, when multiply that by 2, that's what we get. So we say 3 to the power 10. 3 to the power 10 should give us 59049 equals, yeah, that's -1 there. Okay, yeah, so that's going to be 3 to the power k multiplied by 3 to the power, yeah, 3 to the power -1. So that gives us, when you multiply that, okay, 2 times 29520 should give us 59040, and then 3 to the power 10, I mean that's 2 times, yeah, so 3 to the power 10 is going to give us 59049, and then we have -3 to the power k over 3, so 3 to the power -1 is 1 over 3, so that will give us 9. Yeah, I think, yeah, that should give us 9 is equals to -3k, then multiply that by 3. Okay, that is negative there, so it's -9. Let me just rewrite it once again. Yeah, so it's going to be -9 over -3 over k. So that means that we have -9 times 3 is equals to -3 to the power k. So that will give us 27 is equals to 3. So the negative both sides, and then we cancels out, becomes positive. So 3 to the power 3 is 27, and is equals to 3 to the power k. And then 3 to the power 3 is 27. So the base is the same, and then the exponent has to be the same. So that means we have k is equals to 3. That's our final answer. Thank you for watching, and don't forget to follow or subscribe. Any question, please leave below. Tutor Black Adam. Thank you.